All right, so good morning, everyone. Today we're going to have, for the first approximately less than 90 minutes, we're going to talk about managing research teams. So as part of being a data scientist, you don't work on data alone. So you're always working with other groups, other people, other teams, either for algorithms, for just developing systems to manage your data. So we have three distinguished guests with different experiences, different backgrounds. And this panel is just going to be an opportunity for them to discuss how they do research. So what tools they use, how they manage data, how they work with collaborators. And so we'd love a lot of audience participation. So if you plan on leading a research team, we have mostly academics here. And if you plan on being academic, or you plan on leading a research team in a company or in a government lab, so think of questions like, what would you do? What would your research team, your dream research team look like, whether you're leading or participating? So think of questions in that realm, and we'd love to discuss it. So if you have questions or comments, there's a mic right there. So go ahead and go to it, grab it, and we'll start. So we'll start off. I'd like the panelists to please just give a background, say who you are, where you work, and just describe your lab.
Awesome. Although I'm not sure I actually need a microphone. I've never been accused of talking softly, so. I'm Dr. Monica Anderson. I'm from the University of Alabama. My research focuses on cooperative robotics, and I do some work in frameworks as well, but mostly kind of artificial intelligence and human-in-the-loop problems, so how people interact with that human intelligence.
Hi, my name is Tim Winokur. I'm an assistant professor at the University of Notre Dame. I work in graph mining, mostly network science, data mining, and happy to talk to you guys about whatever you'd like to hear about.
Hi, I'm Ivan. I'm a fifth-year PhD student at the University of Illinois, Chicago. I work in the computational populations biology lab there, which is an interdisciplinary lab. We focus on data science and ecology, and I manage a lot of master's students, and I can also tell you quite a bit about my PhD career, where I had 3 different internships in industry, in government, and in research lab. So,
all right. So next, starting with you, Ivan. Can you describe the lab you work in? So who else is in there? Who is over it? And what's the structure like?
Yeah. So we work very, very closely with computational ecology and computational ecologists. So my lab is run by Professor Tanya Brugere-Wolf, and she has quite a few different projects going on with ecologists in the field, and so we have to actually coordinate with them, collect data on our own. So there was a discussion yesterday about interdisciplinary science, and one of the goals of these types of programs is that often in an interdisciplinary setting, people will, ecologists will often treat the data scientists and the computer scientists as programmers, pet programmers, you could say, and the data scientists treat the ecology people, or computer scientists treat the ecology people like the pet data collectors. And so what we often try to do is we try to do very deep collaborative work so that we share both of those responsibilities, so no one's anyone's pet, basically. And so these are the types of projects that we're working on, is working very closely so that we can do both of those different roles. And
cool. Same question to me, I guess?
Yeah, sure.
So I'm a PI and a professor at Notre Dame, and I manage my own lab of about 7, 8, 9 people, depending on how you count. So I have currently 7 PhD students, and I don't have any master's students. Notre Dame doesn't really have a research master's program like a lot of places do. It's we just have PhD students who don't finish all 5 years. Those are master's students. And then we also have a kind of a small cadre of undergraduates, maybe 4 or 5 at any one time that we manage. And if any of you guys want to go into academia to manage graduate students or undergrads of your own, it takes a lot of time and effort and money. So I think the hardest part about managing graduate students is, first of all, to understand their individual, where they're coming from, because it turns out that when you graduate with your PhD, you'll be an expert in something. And you'll be managing people, and you'll be expecting the people that you're managing to have the same concepts and same abilities and same skills that you have. And that's not the case, right? Your PhD students, especially your first, second, third year, they don't know anything. They're undergraduates who just, this is a summer between an undergraduate and a PhD student, right? And so training them and working closely with them so that they can learn the process of research and how to do things properly, and how to become productive in their own right. And then watching them change over 3 and 4, 5, 6, 7 years is really, really rewarding. It's the most rewarding, and that's the reason I do the job that I do, is to mentor the PhD students, to watch them grow and learn. That's the most satisfying part of my job, is to mentor and watch PhD students grow. And then I have one graduated already, 2 more will be graduating in the spring, and they are experts in their own right? They could come and be on this panel or give, I'm absolutely confident that they could be faculty or top researchers at any place in the world because they have gone through the steps and the processes. And so that's really exciting to watch. As far as managing them, there's more deeper questions we can get to later, I think, but that's kind of the introduction of how what managing is like for me.
Okay, I'm also a PI, so I actually have my own lab. I am in a computer science department in the College of Engineering. So what that means is most of my students are CS, but some are mechanical, some are electrical. I also have a physical lab because I'm beyond just computing. I have some physical component to it. So I have about a 1,200 square foot lab, and I've got both undergrads and graduate students. My graduate students actually do not sit in my lab. They actually have office space in another place, and I share an office area with another professor. Typically what I'll do is give my undergrads, I have 4 cubes in my lab, I'll give my undergrads the access to the lab and they'll sit there. I have robots, obviously. I actually bought new robots about a year ago, so I've got about $40,000 worth of hardware platforms. Because I work with hardware, I actually also have a lab where I have bench equipment, so it looks a bit like electrical, but I've got soldering stations and things like that. We do a lot of distributed sensor work with Arduinos and custom circuit boards, so we have space for that. We also, each station has an iMac, and that's only important because we use so many different platforms that we actually have a dual boot Mac OS Windows environment. We also have a site license for MATLAB and for SolidWorks. So a lot of my lab has kind of this physical kind of software, hardware component to it, as well as kind of that data analysis component, which requires MATLAB. Most of my students work on different projects, and there's very many reasons for that. I don't suggest people do that. The way that my funding happens, it's in a bunch of different areas, so I have 1 or 2 students working on different things, so they really don't even work together as much as I would probably like, but it also requires me to kind of deal with students because I don't have a true hierarchy when it comes to managing students. I have to kind of manage the projects individually. So, okay.
So Dr. Anderson, you started talking about the tools you use in your lab. Can you describe what tools do you make people use, or do people decide on what they want, the other researchers or PhD students? And same question.
Okay.
Yes. And also before you answer, so if anyone has any questions, please raise your hand or ask. Thank you.
Yeah, so you caught me actually at a very good time to ask that question. I am like total old school computer science. So if I open up a prompt to do something, I open VI, and whatever I start typing in has the extension .c. Right? And I mean, I'm low level as people can go, but what I've learned is there are not a lot of people like me. So I've had some students do very brilliant kinds of, I have a test bed actually where we do kind of this operator in the loop study where it's a iPad interface with simulated camera feeds and UAVs, and then there's like this other system that does all of the computation and the autonomy, and then another system that actually did all the simulation and all the physics and the generation of the video. And what I learned is there's almost nobody who can walk into my lab and understand that code, let alone change it. And so what I did this summer is I actually spent time and converted it to Python, because I can do Objective-C, C, and MATLAB embedded in my C when I wake up in the morning for breakfast, but most people can't. And to be honest, I've decided that's probably not even what I want my graduate students to spend time on. You know, the test bed is just a tool, right? The research is something very different. So where I had a lot, and then, you know, Java, my programming background is vast, but I'm starting to kind of constrain my footprint in order to be productive. So it's interesting that you say that. And traditionally, we've done a lot of our data analysis with MATLAB, but like everybody else, we're getting away from that, and we're starting to do, you know, Python and Jupyter, those kinds of things where I can bring people in who have those skills versus having to teach people. Nobody really learns MATLAB anymore. I mean, don't get me wrong, I love MATLAB. I mean, I can, again, do anything in MATLAB, but in terms of being productive for my students, again, I'm not training them to be MATLAB people, I'm training them to be scientists. And I find I'm losing a lot of time and energy in having too wide a tool set. So we'll never get away from C or Unix, because we actually do physical kinds of robot things. And some of what we do will always be complicated. But I can't expect every student I bring in to be able to, even a new grad student, I can't drop them into a pub sub architecture with an open source tool chain like week one. So that's been a big thing for me lately.
So I don't ask my students to use any particular software package. When you come to my lab, if you're to join my lab, you would be given a Blade server with about 200 gigabytes of RAM, 64 cores, a laptop of your choosing, a keyboard, a mouse, and a monitor. Nice. And you can use whatever you want. The things that we kind of pride ourselves in our lab is the ideas and the creativity of, you have a question you want to ask, and however you need to solve it, figure it out. So whether you use Java or Python or C++, that's up to your competency and the tool that you think will help you get the job done. Programming is a tool. A computer is a tool that we use to do our science. And so whatever, if you need to use there's 1,000 different saw blades you can use to cut wood. You use the best one that is appropriate for whatever thing you're trying to accomplish. So I think that's what you were talking about as well. You're being much more specific, but I don't care what tool you use, so long as we have a license for it. We have a question. No, go ahead.
I couldn't say it really well. So I guess I'm wondering, with the graduate students whose committees I sit on, I've asked them to kind of constrain the languages that they use, mostly because they're working on tools that other graduate students are eventually going to need. So they're working together to develop a pipeline. And I'm wondering how you kind of reconcile letting them have the freedom to work in the platform environment that they want, with having them develop tools that are broadly portable across your lab environment?
Well, I guess that was towards me, I suppose. We're not developing currently any large open source projects, and so the things that we're trying to do are answer specific questions. And so we have, actually everyone right now is using either C++ or Python. And so I guess that hasn't come up in our lab yet. But everything that we do goes up on GitHub. And if someone else wants to come along and use it, they're welcome to in whatever language that is developed. But I don't expend a whole lot of effort and energy and time to make someone use a specific language. Because that problem, I mean, if that problem were to come up, if some new student were to come in and if they wanted to use that tool that's another student developed in whatever language, they would have to learn that tool. Just as if they found that using Ruby was appropriate, they would have to learn Ruby to use it. Because that would just be another tool that they have to learn to use. Or they develop their own. But that's an excellent point. There are times when MATLAB has some package that you need, and you got to use MATLAB or whatever. And then that becomes another tool that you wouldn't learn. But there are also labs that have software packages that they develop, and then you'd have to force your students to use to learn, because that would be the tool they need to accomplish the science. But that's just one guy's opinion. Ivan.
So I'm at one step lower in the stack than Tim is, which means that I interact with master students quite a bit, which are working on my projects. And in that case, I do a very similar thing where I want them to do whatever they're most comfortable, like to work in the language that whatever they're most comfortable in, and then we'll sort of translate between the two. So that's one group of students, but then there's another group of students and collaborators, which are the domain scientists, and they have very hard constraints because they don't have the same background that we do. So they work in R. Like, that's all that they do is in R. And you can't ask them to do anything different because they're not as skilled to pick up Python or to pick up MATLAB or to pick up all of these other languages. And a lot of their conferences will also request code in R. And so there are a lot harder constraints in those areas. And also, even if you want to work on a draft with them, so a draft in any domain is going to be in Word. And you ask them to put it in LaTeX, and they don't understand. Like, they're not going to work with you in LaTeX. And oftentimes the conferences won't even provide the templates in LaTeX. It'll all be in Word. And so you're trading Word files over email and so on and so on. So there are harder constraints that you just have to deal with in those situations.
And I will say, as a lab manager, I don't concern myself with a whole lot of those details. That's just the PhD student. They're adults, and I assume that they're going to take care of those details. So as far as managing research, that's something that I should probably be more aware of, I guess. But these are difficult challenges.
So speaking of LaTeX, do you guys have any? When you're writing with students or letting students write, do you force them to use LaTeX as opposed to Word at all? Yes.
Oh my gosh, is there anybody who uses Word for papers? Can you do equations? Can you do bib citation? Okay, I was kind of being funny.
That's a new word.
Yeah, no. LaTeX. Yeah, no question. LaTeX.
I say LaTeX.
Just don't do latex. Don't type that in.
Oh. So what about data? How do you guys store data and share data in between collaborators? Is there a set way, or have you tried different sources?
Well, one thing on that previous question, I would expect my students to answer in that section. So when they are writing a paper, they basically start off by answering the individual questions, and that kind of serves as an outline for the paper that they're going to write. And so for the most part, my students write all our conference papers. I mean, I'll proof them and read them, and if they have like 2 misspellings, throw them back and stop reading. But I found that writing papers is not creative writing as much as people want it to. It's very formulaic. And so if anybody wants to see that set of questions, that kind of gives you, at least for the venues where I publish, it actually makes a whole lot of sense to kind of everybody do the same thing in the same place all the time.
Well, let's stay on that point. Dr. Weninger and Ivan, do you guys also train your students to write papers in a certain method, not just the tool?
Yeah, so we use Share the Tech for our paper writing, which it's becoming more and more standard, I think. But as far as, absolutely right, paper writing is the most important, takes the most time, and is the most difficult part of our job. So you can do you can do great research, but if you can't write a great paper, it's not going to make, no one's going to care. So that's part of the, I was talking earlier about like training people to do the work. I was talking about writing papers. So research is, you can ask questions and then do science, and write down results. But if you can't formulate a good research question, then the paper won't fall out. So every paper is built around a good research question. It's like, here's the thing that I want to find out, and here's why it's important. And I had to learn that myself, and I learned that through trial and error. But once I kind of figured that out, then distilling that into the students was also difficult to say, you have to ask a paper is asking an interesting question. The best papers especially ask interesting questions. So what are the questions that you want to do? A lot of people dive into the science and say, I'm going to start tinkering and playing and getting results. But if you don't go into that with an interesting question, then your paper is not going to come out. So I think it's, again, the paper is an artifact of a question and study you did. But that process is important, of asking questions and then having an interesting way of discovering the answer. How to write a paper, that's kind of through, I think, how did I learn that? My students learn it just kind of by reading other papers. So I don't have a template. I like that. Some of the faculty at Notre Dame have a template that maybe I should try. But my understanding is my students read lots of other papers and then just make their paper look like those papers. I could be wrong though.
So one thing that I wanted to mention, so I again work just one level lower in the stack than Tim, and one thing that I did want to mention is that several of us are native English speakers and fluent English speakers, and I helped a non-native English speaker write his first paper, and it's a huge benefit for us to be able to do that because they're working in an environment where it's doubly hard for them because it's hard for us to write papers, but then if you're also dealing with the language when you're doing that, then it makes things even more difficult. And so for the native speakers, if you can really help people who maybe they just barely passed their TOEFL and they can't really write very well, writing that first or second paper is a huge benefit to them. And it's something that we can help out with a lot. And another thing, when you're working a bit lower in the stack, is that you can use the writing process, especially the problem formulation. So if you have a really strong method section to your paper, you can use that method section as a back and forth with the other student to really work out, to really hammer out what they're doing. You can have a lot of board work, a lot of interactive work to make sure that you really understand what's going on and to make sure that they really understand what's going on when they're writing it. So those types of opportunities, when you're writing a paper, you can really work through all of the problems with the paper before you get it. You don't want a paper to escape your lab if it's a bad paper. So you should work out everything internally and then make sure that when you release it to the world that you think that it's a good paper. So.
We also have a collaborative kind of process in our lab that if one person has a problem that they're tackling and they write a paper, even if it's just by themselves or maybe just me and that student, the entire lab will read and comment on the paper. because the constructive internal feedback is really important. And every so often, even when I write my grants, those are circulated internally. So I have 3 or 4 or 5 or more other colleagues read them internally, friendly review. Those are usually the meanest because they know it's coming from a good place, right? If I hate a paper and it's going to get like strong reject, I'm going to be really nice in the review because I don't want to hurt, But your friends will, if they're really your friends, will give you the strongest criticism, the most valuable critique. So I have my papers before they're reviewed, broadly internally reviewed by the lab and by other students as well. And that also kind of helps have other people internally critique each other's writing styles, their question formulation, all of those other writing processes. Anything to add?
And I think that then gets into this idea of managing time. When I started as an assistant professor, our first paper deadline, everybody's in the lab, and I bought food, and we were all there doing the papers. By the following year, if you didn't get me a draft of your paper 2 weeks before it was due, I wasn't going to read it. Because the fact of the matter is some people say, oh, I work so much better when I'm under pressure. No, you really are putting out garbage and you just don't know it. You've got to manage your time as a faculty member, but as a student too, because this being able to have other people read your paper and get that feedback, get you out of the weeds and back up to a high level, but also maybe look at the method section and make the methodology and making sure that you're using all the right tools and comparisons and things, that takes time. It cannot start the day before a deadline and go until 11:59. So teaching students time management, I don't know that you can teach a student time management. I mean, if they're not mature enough to manage their time, I typically drop those students.
Yeah. Can I say something controversial maybe that I don't think that the deadline-driven paper process science that we have right now is beneficial because we put out a lot of papers, a lot of garbage papers because it's a deadline, you have to meet a deadline. Right. Deadline-driven science is not working for me. In fact, the NSF did a thing for, not the SCICE program, but they said no more deadlines, just submit your proposals whenever you want to submit your proposal. And the number of proposals went down by half, which you might think is, well, that's unfortunate. But no, it's great because the 50% of proposals that were just because there's a deadline, I got to meet the deadline, those stopped coming in. So they got better science, less reviewing, and more the higher acceptance rate, right? But the science didn't change. The science is still good. But so this deadline-driven program, I push back on a little bit. I'm submitting more and more of my stuff to journals because I'm just going to submit it when it's ready. And I'm not going to wait until, was it February 6th for KDD? I mean, if I have something for KDD and it's ready to go, then sure, I'll submit it. But I don't encourage my students to go until 2 in the morning to submit a KDD paper if it's not ready.
Well, papers are one way to kind of share your research, and you mentioned GitHub as well. What other methods does the panel use?
Yeah, so I just wanted to mention real quick. So for me, I completely disagree. Almost all of my great ideas have come at 2 a.m. when I'm writing when I'm writing garbage. So the first draft is going to be garbage, but that's when I'm going to get the idea. I'm always going to get the idea under pressure, and then I'm going to improve the idea later. But if I didn't have that pressure, and if I didn't have that drive, then I definitely wouldn't have had that idea ever. And so I've sort of floated around without deadlines, and maybe it's a time management thing, but I love the deadline, and I also love the excitement of it, the excitement of pushing to the deadline. And I think that it actually makes good science because even if you do produce garbage, you're at least producing something. And I mean that in the best possible way because you're going to improve it later, but you're not going to get there. You're not going to get over that hump until you have the pressure to do it.
Yeah, there is. I think there's, and I understand there's a motivation that a deadline gives you, right? If you want to meet a deadline, something's going to get submitted. I agree. Something is going to get submitted. Now, I'm not sure that that's something we want always. But again, KDD does good science. We have deadlines. In computer science, we do good science, but a lot of the papers that we write, not at KDD, but at some other conferences or even at KDD sometimes, the papers that get in sometimes, a lot of the papers that are submitted probably should have waited. But because since there was a deadline, that's what we submitted. But I'm not sure. But again, I agree with Ivan in that there's a motivation that comes with the deadline that, I'm going to get something done. I'm going to get a paper written. But you shouldn't be doing experiments at 2 a.m. On a deadline night, right? Go ahead.
Oh,
The one thing I would say is I like conferences over journals because I like the timely feedback. And sometimes, we'll submit things that are probably not as far along as we'd like for it to be, but sometimes we want to get that feedback from the larger community. And I really like conferences because I like going and talking about my research versus, I've actually submitted journal papers and waited 18 months to get, and by the time that happens, you're like, I can't even remember where I put the tech files anymore. So that it's a trade-off, right? The deadlines are not fun, but the way you get kind of that discourse going in computer science is probably a little broken. That's probably.
Yeah, and I think as normal, the solution lies somewhere in the middle, right? Where there's, VLDB has an interesting thing where it's like a monthly deal, and then you go to the conference and stuff. I don't know what the answer is, but I don't know how we got sidetracked anyway. Yeah, they're all. Yeah.
I was just going to suggest one of the things that we've done in our lab is to allow students whose work is not really totally polished to submit abstracts for conferences, and that they need to have a manuscript ready by the time they go to the conference, and then they get feedback during their talk or poster session, come back, incorporate those comments, and then within like 3 weeks, send their manuscript off to a journal or to a conference proceedings, or however those things kind of work. Depending on the need. But it is, I found a really good motivator because they want to go to exciting places. So they're like, Copenhagen, yeah, let's do it. Yeah. But then it's on them to do the work, because if the work is not done, I'm like, you're not going anywhere, buddy. You're staying right at home.
And of course, I also agree that one of the best parts of this job is traveling to Copenhagen and to Halifax and to these different places and meeting with amazing scientists. This is one of the best parts of our job, is to be able to come to interesting places and do this kind of thing.
Yeah, so I also think that at some point you have a good idea beforehand what's going to happen to the paper. So if something's going to be rejected, you know that it's going to be rejected. But if something's on the border, you can. So there's a sort of cheating thing that happens where you say, okay, let's fix it in the camera ready, which is like, okay, we're going to get it over the threshold, and now if there's anything that needs to be fixed, we can just do it later. And so that's like a second deadline in a way. And I've known people who have used that strategy, is just trying to get it over the threshold and making sure that whatever you do in the next day isn't going to affect the decision. You know what the decision is already. And if you can get it over that line, then you can fix whatever is sort of in post.
So if there's any questions, please let me know. I would like to know, so we talked about papers, and we mentioned GitHub, and we had a question from the audience about, or Latifah mentioned workshops, at least workshops and poster sessions. What other methods do you use in your lab to just communicate the science?
No, I think those are pretty much it. Certainly we have the hallway discussions at conferences, and then you have people come in and do talks, and you go out and do talks. But for the most part, it's, conferences, poster sessions, or for that interactive piece, and then journals. I don't think we do anything outside of that.
No, we have web pages. So on my lab, we, not every, but a series of papers. So sometimes research kind of comes in bursts of, 4 or 5 papers. that becomes a web page. And every one of my students, that's one thing that's kind of mandatory, we'll put a web page up as just some HTML and some images that explains to their mom and dad what they're doing. And that goes up on the web page to say, here's what we're doing. And that's kind of communicated to a broader audience, what we're doing. And also there's a nice little grant number at the bottom that says this is Air Force or NSF is paying for this. Here's why it's important, here's what we're doing. So the web page, and who knows how many hits it gets. I have a tracker, but I don't check it. So that's one. In addition to workshops and conference papers, to speak to to the general audience about what their taxpayer money is going for, I think is mildly important.
So aside from papers, one thing that I got to do in my PhD, which I really recommend, is organizing a workshop, which you can do as a PhD student. Like, there's no rule that you can't organize a workshop as a PhD student. You get people addressing you as doctor a lot, which is fine. I don't mind that. But the thing is that if you want to carve out an area of research and that area isn't very large, then you just host your own workshop. And you can get submissions and do everything in terms of actually organizing it yourself. And I found that to be a huge benefit. And like I said, there's no rule that you can't do it as a PhD student. It's a really nice opportunity. If you ever sort of have the opportunity, either through your advisor or whomever, I really recommend taking it. It teaches you a lot of different skills to be able to do that.
At what point do you expect new students to start producing papers and contributing?
Classes start Monday.
Yeah, no, as soon as possible. Even though my lab tends to be a bit shallow, very seldom do people produce papers by themselves, right? So typically there might be more than one person. I think usually what happens is newer students might start by doing the related work section for somebody else's paper. And then as you get involved with doing more of the methodology, you may write some of the other framing sections. And of course, by the time you're doing kind of your own research, you'll do the methodology and the analysis and those, what the follow-on projects are. So yeah, you're gonna write pretty much when you hit the door. So, just kind of be prepared for that.
You kind of work your way up the author list, right? So in computer science, it's first author, second author, third author, and then the advisors at the end. You come into my lab and you start at like the second to last author, and then as you progress, you work your way up towards the front. That means you're becoming more and more of a sole contributor, but everyone writes the first day, right? That's the most important thing you do as a scientist is write.
Just, for those of you who are scared of writing or hate writing, or you feel like it takes you a really long time to do it and you don't feel like you're particularly good, avail yourself of the training that's available. I went to the University of Minnesota. We had dissertation groups. We had writing workshops. Your advisor will know of some of those. I mean, writing is a skill. Again, not creative. It's not a creative endeavor, really. It's about communicating what you've done. The creativity is in the research, not in the writing of the research. So look for those opportunities and I have a list of really good books that talk about scientific writing and about how to write in such a way that the person who's reading it is following along with you. So the idea would be is the reader should never be surprised by what's in the next sentence, right? Because everything should have a flow, it should have an organization and topic sentences. Make sure that, and do this as undergrads if you can, but definitely as graduate students, do not wait until you are, faculty to decide you want to learn how to write well, because you can't be a successful faculty member if you can't communicate what you're doing, and that's grants, that's papers, but there are a lot of workshops, a lot of good books. Go to them. I mean, they're free. Somebody's paying them. You gotta nail that part of your skill set.
Yeah, I agree. Writing is the most important. I should one before I hand it off to Ivan. I also would say that don't write all at once, because no one can ever write a paper all at once. Instead, if you have like conference 2-column papers, write a column a day or a page a day, right? And you don't go to bed until that page is written. or that amount of text is written. If you do that every day, a column every day, over 200 working days, that's 200 columns, that's 100 pages you've written over a year, right? You just write a column a day. And the most productive people do that. They don't wait until the deadline to start writing, or they don't write when they just write every day. Right?
I'm sorry. I know the other thing, and we didn't talk about this in tools, was citation or bib management. So start off with a citation manager right away. You'll read a paper and you'll say, oh, that's really interesting. And a year from now, you want to cite that paper, and you'll spend a week and you will never find that paper again. So I actually use Cente, which is it's not a cloud-based one. It's actually local to my computer. But for me, it's nice because I can kind of track. It imports all the citations, but it allows me to do a lot of annotations and searching of the annotations.
So I just wanted to say also, so for a PhD student, it's of course our job to write papers, but for any master students and undergrads, I would say it's a huge signal to everyone if you can get yourself on a paper. So you should really take your time and take the time and the effort to go to a professor and make sure that you get on a paper and that you get under a PhD student, because it's going to be a huge signal to that professor. It's going to be a huge signal to future employers and so on. So it's really going to help out if you can work underneath a PhD student and get on a paper. And usually you may even be promoted to the first author on the paper, depending on how much work you're doing, depending on if it goes to a workshop or whatever. So for us, of course, we have to be doing it as PhD students, but everyone else has an opportunity to do it, and it signals to everyone. Like if you see an application for a PhD student and they have publications as a master's, that's a huge signal. So
that's the first thing I look at when I'm looking for PhD students. If we have any undergrads here, master's students, I'm not sure. Yeah, that the first thing I look at, and sometimes the only thing I look at, is have they published a paper before, and that's the skill set you need. I mean, if I'm at an auto shop and I'm looking for a mechanic, I'm looking, do you have experience as a mechanic? I'm looking for PhD students. You know, they're supposed to do research and write papers. I'm looking for experience. Have you done research and written papers before? Right. So it's the same.
Yeah. So I just want to mention sort of one other thing, which is that oftentimes the professor won't sort of go out of their way to put you on the paper. So if you are a master's student, you should really push to make sure that you're writing, to make sure that you're involved in the process. And you have to, I mean, when you're a master's student, you have to chase after the professor. So they're not going to spend much time on you. You get the time allocation based on sort of your seniority, more or less. And so you need to really go really out of your way to make sure that you're on a paper.
You have a question?
Oh, yeah. Speaking of how good publications look, what about publications that aren't in the same field? Like, say that you're applying, hypothetically, you're applying to something in computer science, like, you know, because we're KDD. But what about people from different fields who switch over, like maybe chemistry or biology or physics? How do those look?
It's fine with me. Yeah, I mean, it would be better if it was a KDD, but science is science. And if you've written papers before and you've done the work, if you be a diesel mechanic versus a gasoline mechanic, it's still evidence that you can do science and write science and contribute to your whatever field you're in. So I give that as not 100% plus, but a 95% plus. That's perfectly fine. Do you agree?
Yeah, no, I agree.
So one impediment to a lot of undergrads and master students is finding an idea or finding something worth writing about, especially for the first time. So do you have any suggestions of how they can get started?
I'm sure what everybody else is going to say is the big one: look at somebody else's related work and see what problems they feel they left open. I will say that when I started graduate school, and my first advisor, his comment to me was, it doesn't matter what you do so long as you do something. And so, we get kind of this analysis paralysis where we think as freshmen, I'm going to sit here, I'm going to solve, the AI, the computer vision, the whatever problem, and you sit there until you think you've solved it. That's not how life works. I heard somebody say yesterday, help a grad student on their work. I actually did that. I had a grad student who was senior to me. She was working on her dissertation. I did some of the coding for her, and I learned a lot about problems in that experience. So I think if you trust the process, and the process has worked for everybody before you, it's not so much about having that revolutionary idea in the beginning. It's about doing stuff. Do as much stuff, different stuff, work in different labs if your school kind of has that environment. But your idea is going to come while you're working on something.
And as a different angle to the same, I agree with that. As a different angle to the same question, is every KDD paper at the end will have a conclusion section, and the last paragraph before the acknowledgement section is stuff we didn't do but would like to do. All right, so that paragraph, or 2 or 3 paragraphs, is stuff that you can do. So you download their code and their data set and perform what they said they wanted to do but didn't do. And now, a lot of times they've already done that and they just haven't written the paper yet. They'll leave the most interesting stuff, keep it to themselves. But if you read enough, then the ideas will come to you. So read and go to tutorials, go to conferences, talk to people, and of course, work with other grad students, especially if you're new to the process. Your job is to kind of work your way up an author list. So start as the last author and then work your way up towards the front. And towards the front means that you led the project and you did all the work, versus you wrote the related work section in the paper. So, yeah, but do something. Be productive and talk, and be active and be tenacious in whatever you're doing.
And I also think that, so this is sort of addressed to maybe first and second year PhD students or younger. I would say to use that time to also explore different labs. So when you explore different labs, you're able to do kind of an A/B testing. You're able to see how your ideas are playing off the professor and how the ideas are playing off the other lab. And so in some labs, you may get an inroad of a PhD student who wants to work with you, or a postdoc or whatever who wants to work with you, and something catches, or maybe, you don't want to be spending all of your time sort of invested in one particular person that's going to be able to jumpstart your publications. And so I think using that, people are expected to use that time to explore, and sort of exploring to the maximum, I think, is probably the best opportunity. And then when something catches, you have someone there that is you have maybe multiple people there that are going to help you out. So.
If there's no, go ahead.
Just one quick comment, and feeding off what you said. A PhD is where more than one person in the department thinks you should graduate. So this exploration is a bit about building some of those other relationships of your committee members. You want your committee members to kind of know what you're doing, understand kind of your skill set, but you kind of want them to have a vested interest in seeing you succeed. So yeah, they read your dissertation before you defend it, or they're willing to kind of do a look at a draft of a paper that you're writing. So that exploration early on, I think, is really key in kind of building your departmental support.
So if there's no other questions, just as a final question for each of the panel members, there's a lot of different lab types, right? Everyone here is in academia. There's also government labs. There's research labs in industry. There's privately funded labs or startup research labs. Can you explain or say why you think academia is the best, or what other options people should consider when thinking about starting or joining a lab? It's basically time for you to talk about your lab.
So this is why did I choose to be a professor? I think. So I've been at Microsoft Research, and I work closely with the government labs, and I don't. In academia, you get to teach classes, which I really, really like. Some people aren't like, want out of their course load. I really like teaching. Monday, Wednesday, Friday at 9:30 in the morning is my favorite time of the week. So I enjoy that part of academia, but as far as the research angle goes, government labs and academia, and even like Microsoft Research or Google Research, I think they operate really similarly. You do your work, you have a cadre of either interns or PhD students or folks, if it's at Google, folks who don't have their PhDs and they're working in your lab with you. You have more freedom in academia. I can do whatever I want. And no one can tell me no, which is remarkable and amazing. So the freedom is excellent. I get to teach impressionable youths, which is important. I really enjoy that. But as far, I don't think there is some difference in freedom, but I don't think there's a whole lot of practical difference at other places.
So before I finished my PhD, I actually did both a corporate experience and I also did a summer at the Army Research Lab. And I agree with you, there wasn't a bunch of difference except for kind of the freedom thing. In a company, if you're doing research in an area that doesn't have some tie to kind of what their products are or how they make their money, it's kind of a dubious place to be. I actually did my corporate at Avaya Labs, and my mentor actually got laid off so my going away party was also his. So that was, I checked that box, don't want that job. But I mean, what he was doing probably wasn't as closely tied to what it is they wanted, and he actually became an academic. I was at the Army Research Lab, and that's really applied, right? And I think what they do is absolutely great work, but it's as they talk about 6.1, 6.2, it's really applied to very specific problems, which is rewarding and is great, but also a little limiting depending upon how you look at it. So that's why I'm an academic.
So I'm currently making this decision, and I think that one of the big things to decide on is, so Tim loves teaching apparently, and loves actually mentoring students. And I've mentored several master students, and that's okay, but it's not my driving force, I think. And so if you don't love teaching, you don't really love mentoring students, I think that probably other avenues are better for you, especially if you don't love teaching or if you really dislike teaching. And so those are just decisions that you should make. But so I also had the experience of a government lab internship and a private research lab internship, and I can compare those two. So the private research lab for me was a bit disappointing because it was very focused on patents, and so you were evaluated based on how many patents you got per year, and it was like 60% of your evaluation was based on patents. And so if you don't mind that your research is being tied into sort of an IP, intellectual property database, and that's really what the company is doing, then it's great. Like you can do sort of anything that you want within certain parameters, and those parameters are pretty broad. But if you don't mind the ownership of that intellectual property, then I think you can really thrive in that environment. And similarly, if you don't mind, so I was also at Lawrence Livermore National Lab, and as long as you don't mind that your research is sort of broadly focused on some national interest, then you can thrive there as well. And if you like paperwork, if you love paperwork, you should go to Lawrence Livermore National Lab. It's really good. So that's another thing, is there's a bureaucratic overhead, and just because of the culture of those types of places. And so these aren't small decisions, patents and overhead and these things. Like you spend a lot of time doing this, and so I think that you should really focus on those things, because you're going to be, like, for me, that kind of overhead is all that I think about, and I don't want to be thinking about those types of things. I want someone else to take care of a lot of those things.
So in academia, there's also a lot of that bureaucratic paperwork. We just shield the graduate students from that. I say probably 10-20% of my job is filling out forms. And so that happens in academia as well. Another thing that I didn't mention, that there is limitations in academia. One of the things that we don't have is data so much, unless we want to spend a lot of money and time collecting it. Facebook and Microsoft and Google and Avaya and all these companies have great data sets. And we're data scientists. That's one of the really attractive things about working in private industry. And so there's a big positive in that. And then one of the things that I struggle with weekly is finding interesting ways to collect and solicit data. So that's one complication that comes with working in academia. But again, it's pros and cons of everything, right? There's pros and cons to any kind of industry and choice that you make.
So we didn't get to talk about a couple things like data management, like you mentioned earlier, but I think that is the time. And so please give our panel a hand.